Okay, so finishing up question number 13, it wanted to know how much larger must the copy be. In other words, it's looking for magnification. Negative di over do. So negative 66 2/3 centimeters over do was 40 centimeters. So m is equal to 2 goes into both, 33 1/3, and divide that again. 3 1/3, 1.6 repeating, I think. 1.6 repeating times, and it's a negative, where the negative, remember a negative on the HI means inverted, and so a negative on the magnification also means inverted. Okay, because this negative didn't come with the di, it's in the equation, so it means it's inverted, which of course means it's real. Okay, if the negative is on the di up here, it means it's virtual. But because the negative was in the equation, giving us an overall negative on the magnification, because the di was positive, it means inverted and therefore also real. All right, number 14. Camera lenses are described in terms of their focal length. A 50 millimeter lens has a focal length of 50 millimeters, imagine. Okay, so what is this? 14. So f, 50 millimeters. A camera is focused on an object that's 3 meters away. Do is 3 meters. Using the 50 millimeter lens, locate the position of the image. Okay, so I'm going to change this one. Maybe I'll change this to 5 centimeters, and I'll change this to 300, just because I don't like really huge numbers. And since it's 50, or you could do 50 and 3,000. So 1 over f is equal to 1 over do plus 1 over di. We're looking for di. 1 over di is equal to 1 over f minus 1 over do. Now, remember we had talked about in an earlier video that whenever the object is close to infinity away, the di should be close to the f. Well, 3 meters compared to 50 centimeters, this is going to be close to infinity. I bet our di is going to work out to be something really close to 5 centimeters or 50 millimeters. Okay, so 1 over 5 centimeters minus 1 over 300 centimeters. Common denominator is 300. So 1 over goes in 60 times, so 60 over 300 minus 1 over 300 is 59 over 300. Flip it, divide, and you should get 5.08475 centimeters. Or if you want, 50.8475 millimeters, which is really close to the focal point, right? So the object is acting like a distant object. Part B says 1,000 millimeter lens is focused on an object 125 meters away. Locate the position. So this time, f is, it's 1,000 millimeters, and the image is 125 meters. Okay, these numbers are going to be messy no matter which way we do it. I'd probably switch this to meters. 1 meter. 1,000 millimeters is 1 meter, right? So 1 over f is going to be 1 over do plus 1 over di. So 1 over di is going to equal 1 over f minus 1 over do. So 1 over di is going to equal 1 over 1 minus 1 over 125. I think the denominator might be 125. So 125 over 125 minus 1 over 125. 124 over 125. Flip it and multiply. 125 over 124. di should be equal to 1.001 think there's only 2 zeros, 8, 1. So again, it's acting like a distant object. The DI is really close to the F. All right, number 15. Solve problem 10 using a lens rather than a mirror. So we did problem 10 earlier, one other day, but it was with a mirror. So it said, a production line inspector wants a mirror that produces an upright image with a magnification of 7.5. So M is 7.5 times as big. And an upright, which means it's going to be virtual, when it is located 14 millimeters from the machine part. So DO is 14 millimeters, and from this we can get DI, because we know M is equal to negative DI over DO. So rearranging, DI is equal to negative M over DO. So DI is equal to negative 7.5 times 14. 15 times 7. 105. And it's going to be negative because, is it millimeters? Yeah, it's going to be negative because it has to be virtual if it's upright. So the question wants to know what kind of mirror would do the job, except now it's what kind of lens. So it's gonna, you want it to be bigger, it's gonna have to be a convex lens. And then, oops, I better write the word lens here. Just because it's not, was a concave mirror when we did question 10. And what is its radius of curvature? So really it's asking for 2F now. So 1 over F is equal to 1 over DO plus 1 over DI. So 1 over F is equal to 1 over 14 plus 1 over 105, which is negative. Common denominator should be 210. 1 over F is equal to 15 over 210 minus 2 over 210 is equal to 13 over 210. So F is equal to off the screen, is equal to 210 over 13. So F is equal to 16.154. And therefore, R is equal to 2F. And so that'll be 32.308, which, if you look back, is exactly the same answer as we got when we did it for mirrors, because they parallel each other. And the last question. The last question says, a convex lens is needed to produce an image located 24 centimeters behind the lens. An image that is located 24 centimeters behind the lens. So DI is 24. That is 0.75 the size of the object. So M is 0.75. I can't, what should the focal length be? Convex produce an image that, okay, so, and it's behind the lens. So behind the lens means it's going to be real. And so this 0.75 has to go in as a negative, because we know if it's real, it means it's inverted, and inverted is a negative. So negative DI over DO, we can find our DO. DO will equal negative DI over M. So that's equal to negative 24 over negative 0.75. That's like 3/4. So flip 832. So DO should be 32 centimeters. But the question wants to know focal length. So now we can do 1 over F is equal to 1 over DO plus 1 over DI. So 1 over 32 plus 1 over 24. Common denominator should be 96. So 1 over F is equal to 3 over 96 plus, did I do that wrong? 4 over 96? No, I think I did it right. 7 over 96. 96 over 7. f should be equal to